just a review over the practice we had last class period. So number one does have a GCF, and then we're going to end up using the rooftop method. The GCF is going to be a 3x. So when I take a 3x out of all of these, then I'm left with x squared, x, and a 2 right here. Again, 3x times x squared gives me 3x cubed. 3x times x, negative x, gives me negative 3x squared. 3x times negative 2 gives me negative 6x. And then now I can concentrate on this. For the rooftop method, there is a 1 there, so 1 times negative 2 is negative 2. Two numbers that multiply to get negative 2, that'll sum to get negative 1. 1 and negative 2. So then when I factor this, I'll have 3x as one of my factors times x plus 1 times x minus 2. And so that is my final answer for number 1. Number 2 is a grouping problem. So we have 4 terms. So when we use grouping, I group the first 2 together and the last 2. I look for the GCF of the first 2 terms. In this case, it is x squared. And then I have x plus 3 inside the parentheses. Same concept. X squared times x gives me x cubed. X squared times a positive 3 gives me a positive 3x squared. Then I do the same thing with the last 2. The GCF here is a negative 1, so I go ahead and write a negative 1. And then inside parentheses, it is x plus 3. Negative 1 times x is negative x. Negative 1 times a positive 3 is a negative 3. And so this is what we're looking for. We're looking for the same factor inside parentheses. So I go ahead and write that out. And then I take this term, x squared, and this term of negative 1, and I make that my second factor. This is usually your final answer, but we do notice that this factor is the difference of squares, so then we can go ahead and simplify this one more step. So x squared minus 1 splits up to x plus 1 times x minus 1, and then we just drop the factor of x plus 3. So then that is my final answer. All right, for number 3, we have the sum of cubes. Okay, so again, if you need to, right, we find a and b, which is simply the cubed root of both of these values. So a is just x, b is 3, and then we just follow the formula that is on our formula sheet, where we have one factor times another factor, and we're going to have a plus minus plus. So this is just going to be x, this is going to be 3, this is going to be x squared, this is going to be 3 times x, which is 3x, and then this is going to be 3 times 3, which is 9. And then I'm done. So again, this is a special one. That was the sum of cubes. Number 4 is the difference of cubes. Okay, so same process. I'm going to have 2 factors. This time it's going to be minus there and plus plus. So again, I'm taking the cubed root here of both of these terms. The cubed root of 8x cubed is just 2x. The cubed root of 125 is 5. And then this first term is basically 2x times 2x, which gives me 4x squared. The middle term is 2x times 5, which is 10x. And the last term is 5 times 5, which gives me 25. And I'm done. The difference of cubes. All right. Looking at number 5 and 6, this is going to be the difference of squares. Okay. So again, on your formula chart, difference of squares, one's going to be minus, one's going to be plus. So I can do that for both of these because I know that these are the difference of 2 perfect squares. Number 6 is actually the easier one, so again, we're just taking the square root this time of both terms. So that's x, square root of x squared is just x, the square root of 49 is 7. So x and 7 go in the first and second blanks right here. For this one's a little different because it's x to the fourth. Well, we can say x squared times x squared gives me x to the fourth, right? Or the square root of that is this, and the square root of 36 is 6. So basically, first term times first term gives me first term. Last term times last term gives me last term. That's difference of squares. With number 7, 8, and 9, this is actually the same as 8. So this is a perfect square trinomial. Again, if you don't recognize this as a perfect square trinomial, then you can always use the rooftop if you want method. Since it tells me it's a perfect square trinomial, then I can go ahead and use my my formula. So this is going to be 1 factor squared. It's going to be the exact same factor. This is plus plus, so that's a plus. So all I do is take the square root of that, 2x, square root of the last term, 3, and that's my final answer. Okay, and then for number 8, same thing, plus plus. So we're going to have that, and then I take the square root of that and the square root of that. That gives me 5x here and an 8 there. So again, if you don't understand what I'm doing, use the rooftop where you would multiply that out and then find your 2 factors. You'll get to the same answer, just it'll take a little bit longer. All right, on the back side, let's see here, difference of cubes. Okay, so difference of cubes this time, just kind of like we did before. I use my formula, and the difference is going to be minus plus plus, and again it's cubed, so I'm going to take the cubed root of both of those. So this is just x, this gives me 2y. So then this first term is x times x, which is x squared. Middle term is x times 2y, which gives me 2yx or 2xy. It doesn't really matter the order that you write it in here. And then the last term is 2y times 2y, which gives me 4y squared. And that would be my final answer. Okay, I'm going to skip 11 and 12 and move on. Finding the inverse has given us problems. This is just solving equations. Okay, for the inverse, I have to switch x and y. Okay, and then I'm solving for y. So at the end of this, I want it to say y equals. So that means I have to get rid of this 3, that cubed, and that minus 5. This is where I use the PEMDAS method. So PEMDAS versus SADMET. Okay, so PEMDAS, if y was a number, I would first add 3. Then once I figured that out, I would cube it. And then I would subtract 5 at the end. So 3 steps to get there. So it's going to take 3 steps to solve, and I work from the bottom up now. So I'm going to add 5, take the cubed root, and then subtract 3. So first thing I do is add 5 to both sides. This gives me x plus 5 is equal to the quantity of y plus 3 cubed. Then I take the cubed root of both sides. That leaves me with the cubed root of x plus 5 is equal to y plus 3. And then the last step, I subtract 3 to both sides. That gives me the cubed root of x plus 5. That's underneath the square root. And then the minus 3 goes outside of the root. I cannot combine 5 and 3 because one's inside of the root and the other's outside. So this is my final answer. And then let's do B. When I want the cubed root, it wants me to write it as a rational exponent. So that goes with the rule of A over the power of m over n, and that's going to be the nth root of a raised to the power of m. So we can go back and forth between the two, so we're going to use this method right here. So I'm going to rewrite it as all fractions. So this one is basically saying I have the cube root of 8 times the cube root of x to the 6th power times the cube root of y times the cube root of z to the 9th power. So I convert all these to fractions, except this one I can calculate. That's 2. This gives me x to the power of 6 over 3, y to the power of 1 over 3, z to the power of 9 over 3, and then I just simplify these fractions. So this simplifies to 2, that stays that, and 9 divided by 3 gives me 3. So my final answer here is 2x squared y to the power of 1/3 z to the power of 3. Alright, and then the last thing that I'm going to do is this last problem. We will need our calculator in just a second. So I'm going to go ahead and plug this into my calculator, and then I'll start solving the rest of it. Alright. So this is what my graph looks like. First thing I'm going to do is it wants me to state the transformations. So this is A, this is C, and that is D. So the negative tells me a reflection over the x-axis. -1 tells me that it moved right 1, and the +8 tells me up 8. And then again, I come back to here to kind of look at my domain. I'm going to adjust my window just a little bit. Let's go 30 there. So that's what my graph looks like. The domain, it goes to negative infinity, positive infinity. So the domain is all reals. The range is also all reals. It goes negative infinity to positive infinity. And then it wants the x-intercepts. So that one right there, you can kind of see clearly that it does pass 3. If you wanted to find the x-intercept, again, y2 is 0, and then I just find the intersection of that, and it does give me 3, 0. So the x-intercept is at 3, 0, and then the y-intercept is the one that's tricky to find. So that one's a little bit harder. So I go to my table, and the y-intercept is when x is 0. So when x is 0, I have my y-intercept. So my y-intercept is at 0, 9.